Hello everyone, we are batch D11 from the CSE department at Gokaraju Rangaraju Institute of Engineering and Technology. We are excited to present our final year project titled TuneShift, Musical Transmutation and Fusion using Diffusion Models. Our team consists of Afan, Bhuvan, Rikhil, and Anil. We carried out this project under the esteemed guidance of Professor G. Mallikarjuna Rao from the CSE department. Music creation is a time-intensive and technically demanding process. Musicians often struggle to generate new ideas, switch between instruments, or merge diverse tunes without relying on expensive tools or expert skills. Our project TuneShift addresses this challenge using AI-powered diffusion models. The idea is to empower musicians by automating three key tasks: generating fresh background music, converting melodies from one instrument to another, fusing multiple musical tracks into one coherent composition. We leverage spectral representations such as MEL spectrograms and chroma features using libraries like Librosa and SciPy to process and analyze audio. We trained the models using PyTorch with data augmentation for tempo and pitch variations. We also used PyDub for audio slicing and reconstruction, and Matplotlib for visualizing training curves and audio features. The front end allows users to upload audio files and choose from various transformation modes, such as instrumental conversion or musical fusion. We have provided drop-down menus to allow users to adjust parameters like pitch, tempo, and volume. The interface is built using JavaScript, and users can preview changes in real time directly within the browser.
So, as we said, our project has three purposes. One of them is music transformation. So, in this web interface, we are implementing music transformation using diffusion models. The process begins with a forward diffusion approach where we gradually add Gaussian noise to an existing background music score. So, the web page includes a button which is to choose an MP3 file, and there are certain parameters which are pitch shift, time stretch rate, low cut and high cut frequencies. With these parameters, we will be doing audio processing, which is the initial step. So you can choose an MP3 file from your local storage. So I can select one of the MP3 files and give certain parameters and click on generate tune. So this transformation is guided by a specific user defined parameters as we mentioned here. To handle the initial audio transformations, we utilize Librosa library. It's a powerful audio processing library. This stage involves modifying original audio based on the input parameters to prepare it for the diffusion stage. So following this, we apply a diffusion model that continues the process by introducing controlled Gaussian noise to the audio processed file. The model then learns to add noise and reconstruct the signal, aiming to generate an output that retains the structure of the original but with the alterations based on the parameters given. So our primary objective is to produce a tune that is similar to the original one but altered with certain characteristics based on the parameters. So this is useful for musicians and audio editors and those who love music and try to modify their background scores. So this is the original input. And this is generated by our model. So in this model, we have used forward diffusion, that is adding Gaussian noise to the original background music score. And if the user likes the generated output, he or she can simply click on the download button and save it in their local disk. Coming to the second purpose of our project is instrumental conversion. So here the users will be able to convert from one musical instrument to another one. This is done by using diffusion models, the same concept that we used for musical transformations. So the users can select the MP3 file of the original instrument. Here we are choosing guitar and trying to convert it into piano. So we'll be using the same diffusion models. So the users can upload MP3 file of the original instrument. So here we'll be selecting a guitar MP3 file. This is the original MP3 file of the guitar, and by submitting, by clicking on the convert button, our diffusion models gradually add noise to the original sound and then learn how to remove the noise in such a way that it reshapes the sound to match the target instrument. So during this process, the model learns the patterns, textures, and tones of both original and target instruments. And while denoising, it doesn't just restore the original, but it reshapes the sound to follow the characteristics of new instrument while keeping the notes and timing same. So here is the original audio file, which is of guitar. And our model has converted it into piano. So in our project previously we have seen how our model converts from one instrument to another, that was from guitar to piano. Now here I'll be showing how our model converts from guitar to flute. So here is the original guitar audio clip which we have given as the input. And our model has converted it into flute. So this was instrumental conversion where we tried to convert from one musical instrument to another using Liberosa Python library and diffusion models.
Thanks for watching. If you have any questions or suggestions, feel free to reach out to us. You can contact us at the following emails. Thank you.